picture is pretty straightforward. For instance, we know why, even if Yeniseians and Na-Dene are one group and one language family, why nothing in between is related. That's pretty obvious because the second of the three revolutions that I was telling you about happened about 3,000 years ago in Inner Asia, and that is the domestication of the Asian reindeer, Rangifer tarandus. And this caused a movement of new peoples from Manchuria and from the Altai region, the ancestors of the modern Samoyedic peoples, the Ugric peoples in the Uralic language family, the ancestors of the Evenki and Evan peoples and Tungusic peoples, to move up and basically recolonize all of North Asia except for that very mosquito-y cat area, or the areas along the coast that had hunter-gatherers that were oriented towards the rivers and the oceans. So this means that 3,000 years ago, whoever was originally living in all of the rest of North Asia, whatever their languages were, whatever their cultural affiliations were, it got submerged under this reindeer revolution that occurred. All right? So that's something we know pretty clearly. Y chromosome DNA is a very important picture to look at any kind of study across Bering Strait, passed down only from father to son. Okay? And when we look at the Y DNA of the cat people, we find that the major haplogroup of the cat people is Y DNA haplogroup Q. I believe it is Q1, which is a cousin haplogroup of the one that is predominantly found in Native Americans, all Native Americans in both North America and South America. So the cats among the people of North Asia share this very distant connection where maybe 15, 16, I'm really hesitant to say how many thousand years ago, almost 90% of modern cat men and maybe 90% of Native Americans before the coming of the Europeans share a single male ancestor. And the cats are special in North Asia because that Q haplotype is not found very far else. It's found even as far as Norway or Iceland. It's found in Central Asia, but the haplotypes outside of Siberia seem to be a little bit more distantly related. And only in the cat area, and you can see this on the map here, do you have extreme concentration of that particular haplotype, cousin haplotype of the ones in native North America. And you might think, wow, this is already evidence that the language relationship must be the case. But in fact, this is two very significant obstacles to the possibility of that language relationship. Very important. If the cats have a relationship through the male line with all the Native Americans, why do they only have a language relationship with just one of the families there? That's a super important question that I hope to answer today. And also, we're talking about time depths that's 13, 14,000 years. It's longer ago than 10,000 years, and linguists generally say that language evidence of genetic relationship erodes so that maybe by 10 or 12,000 years ago you really can't demonstrate anything anymore. So I have to explain how it is possible to demonstrate anything when I'm talking about a time depth like that. So these are these two fundamental questions. If I can't answer those, you shouldn't even look at the data on the language relationship. So that's what I'm going to try to do today. Okay? Mitochondrial DNA is something else to look at. And often, mitochondrial DNA tells what looks like it's a little bit different story, just like what we just heard about the Aleuts. All this European Y DNA in the modern Aleuts, and the mitochondrial is still a lot of what had originally been there. Sometimes it's going to be the other way around. When we look at mitochondrial DNA of Native Americans, and this is better known to this audience than it is to me, so I won't go into details. We have what looks like 6 major founding haplogroups, but it's even more complicated than that because we have subclades of these haplogroups that probably also go back to the general window of time where the first migrants went into the Americas. So the mitochondrial DNA of Native Americans is more complicated and of more diverse and more ancient origins than we have with the Y DNA, which seems to be predominantly one single haplotype. Right? Na-Dene, very interesting. They only have predominantly one of those haplogroups in their in the mitochondrial DNA. It's predominantly the A2 haplogroup, and that is going to turn out to be significant. Okay. All right. When we get to the cat, we find that the cat has a unique combination of different mitochondrial DNAs. We have A, which is cousin of the A that we find in Nadine, but also all the way down to South America, cousin of that as well. We have C, which also has some very distant cousin relationships with mitochondrial DNA in Native America. But we have H, which is from Western Eurasia, having nothing to do with Native America. And we also have a significant portion of very ancient subtype of the U haplogroup, and also a very ancient subtype of the F haplogroup. The U is some of the earliest that goes into northern Eurasia, northwestern Eurasia, and the F is something that is mostly found in Southeast Asia today. The cats are unique in having those combinations, and no one else in Siberia has this combination in modern Siberia. Okay, the H probably comes recently from peoples coming with Indo-Europeans, admixture with Uralic peoples who had mixed with Indo-Europeans. It doesn't seem to be very anciently represented specifically in this cat population. The C seems to be closer, come in with the reindeer breeding peoples who intermarried with the cat people. Now the haplogroups A, U, and F appear to be more ancient. We don't find any evidence that they have been recently introduced from any other population to the cats, and so they're more interesting for understanding cat origins. And fortunately, an important archaeological project has been going on for a number of years in the southern part of Lake Baikal, not so far from where linguistic and toponymic evidence suggests that the ancestors of cat peoples originated, at least were located there 2,000 or 3,000 years ago. This Baikal archaeology project has unearthed burials of ancient fisher folk along the very southern tip of Lake Baikal and the Angara River that flows out of it. And it turns out that the mitochondrial DNA in these ancient fishing burials contains a very high percentage of F haplotype and also U haplotype. And these are the same ones that are present in modern cats and in no one else in Siberia. And it is highly likely that these people who are in what is called Kitoi culture of hunter-gatherer fishers are at least a significant segment of the female ancestors of the modern cats. Okay, and that only leaves the A haplotype. Okay, and so what my hypothesis is the following: that the cat people, modern cat people, derived from male hunters, upland hunters, carrying that same Q haplotype, and they are the ones that brought the language. That is associated with the actual cat language itself. In historic times, the cat people were patriarchal. They were exogamous. It was the males who controlled the society, and women, females from other groups were inducted into the cats, and they became cats. They became speakers of cat. Their children were speakers of cat. So there was a male-dominated exogamy. My suspicion is that this is partly why the mitochondrial DNA is so much more diverse among the cat, and the male is not diverse, and in my opinion is ancient and connected with the language. My hypothesis, the original mitochondrial DNA, if there was a predominant one that was associated with this earlier hunting culture, was the A haplotype. And the U and the F were added by exogamous connection with these ancient fisher folk, probably had a maternal culture on the rivers that were in the southernmost area of the Lake Baikal, where modern cat people seem to have originated. And the haplogroups A, H, and C in the mitochondrial seem to have come from later admixtures with people from either the east or the west. Okay. Now we finally can ask some questions and hopefully get some answers to interesting questions. First of all, if the cats share their Y DNA distantly with all Native Americans, or almost all Native Americans, why do they share only with one of the many, many dozens of Native American language families a language link? Super important question. Second question, why do certain groups of Native North Americans, like particularly the Athabascans, have predominantly just one of these original founding mitochondrial haplotypes? And in the case of the Nadine, it's one of the subclades of A haplotype that is also in a minority in the cats, but a distant cousin of it. All right, is there a reason for that? Is there something interesting in the origin of these peoples? The Algonquids also have quite a bit of the A, and when you get down to South America, you have some of the same haplotype or cousin of it, but it's not nearly in as large a proportion. So what is there a reason for that? Right? Then the third and last question. The Na-Dene people are different in their Y DNA from the rest of the American Indians in North America and in Central and South America, in that they have another male haplotype that is fairly largely represented in that particular population, and that is the C3, a subclade of the C3 Y DNA haplotype. And this is very represented by males in eastern Siberia, much less in western Siberia. And so this is an important piece of the puzzle as well. So why is this the case? Why do just the Na-Dene have this male haplotype and not the others? Okay, let's start with answering question 3, because that's the easiest and the most straightforward. The ancient male DNA haplotype C, the haplogroup, is very, very ancient. But the subclade that is in North Asia, C3, and that a variety of it is predominantly in the areas that are Na-Dene or other Native Americans that were known to have interacted with Na-Dene. You can see that haplogroup here looking like where the Na-Dene language family is located, and that's not a coincidence, I think. Obviously suggests that this particular group must have been in North Asia at least a little bit longer than the original migrants in order to pick up that C3 haplotype that was moving up from Eastern Asia. That would be the answer to this. Now, this C3 haplotype is also found in the modern Manchurians, modern ranger breeders that took over much of northern Asia, and it's also the one that had a variety of it by Chinggis Khan, and he messed up the picture a little bit. Because, as you may know, his genealogy spread this haplotype far and wide wherever the Mongol Empire was located. And some people think that Chinggis Khan himself had something like 16 to 20 million descendants, literally descendants from this. And so how did he do it? Well, you know, he didn't have Ferrari, it was Mongol cavalry. Okay, so it's pretty straightforward how this occurred. But if you take away that, you see that the C3 is pretty much concentrated in this eastern northern Asia, and also a variety of it, an early variety of it, is only concentrated in Na-Dene area. So it looks like the Na-Dene must have been in North Asia long enough to pick it up before they went over, and that means that they probably were a little bit later migration than the first migration or migrations that brought in the earlier language families. That seems pretty straightforward. Now we get to some interesting things. Why does the mitochondrial DNA of Native Americans so much more diverse than the male DNA, the Y DNA? Okay, that's a very important question. And why does the Ket only share the Q and the A cousin haplotypes with the Na-Dene peoples? All right, now we can start answering this question. My hypothesis is this. The rise of cultures that started hunting as the Ice Age was ending, using microblade technology that became to be the Juktai culture in North Asia, a highly successful culture. My hypothesis is that a predominant male haplotype was Q, one of the varieties of Q, and predominant female haplotype was A. The various clades of B, C, D mitochondrial DNA haplotypes probably were already present in the Pacific Rim area before the entry into the Americas and before the spread of this microblade hunting culture. What were the male haplotypes that went along with that before the spread of this Juktai culture? We don't know, because they got supplanted. And this microblade hunter Q plus A dispersal hypothesis, for want of a better name you could call it, would show what was the first really major revolution that happened in North Asia, and that was the spread of big game hunters using microblade technology. And these people were so successful they didn't need the Mongol cavalry, they had the microblade, and that was what allowed them and the males as well as females